Hey guys, sorry I can't be there to teach you this lesson in person, but today we are going to talk about solving exponential equation word problems using logarithms, which means that this time around we're going to be solving for the time given a new total and the original total. So just a couple of quick things. Make sure that you have the notes packet and that you have a calculator because you're going to need both of them. Remind Mr. Ralston that he has papers that need to be passed back. You guys can help him pass those back. Yesterday I posted the 2 keys for the quiz reviews, for the quizzes that you took for this unit. They're in your Google Classroom right after this announcement, so make sure that you use them as good study guides. Everything that was on those quizzes are also going to be on your test, which is on Friday. Okay, so let's get started. Here are some formulas that you might need for solving the word problems, except for Newton's law of cooling. We're not going to use that one at all, but the top 4 are all fair game. For your test on Friday, you will be given a formula sheet with these problems on it, but you need to know how to use them. Okay. So this word problem might be familiar. We've got a painting that is sold for $1,400 and its value increases by 9% each year after it is sold. So what kind of exponential situation do we have? We've got an exponential growth. So here's the formula that we're going to use. Okay. Last time when we were using these formulas, A was Y and P was Y sub 0. They're the same thing. P is the initial value, R is your growth rate, T is your time, and A is your new value. So here's our situation, and we want to write a function rule for the situation, which means that we're going to write this exact thing down, but we are going to insert the values for P and for R. The initial value was 1,400, and the growth rate is 9%. You need to write it as a decimal. Move the decimal point 2 spaces to the left, or take that 9 and divide it by 100. So the question that we need to solve is how long will it take for the value of the painting to double? What does it mean to double? Multiply by 2. So here's our formula again. We're looking for the time that it is going to take for the painting to reach $2,800 in value. So A gets replaced with 2,800. Everything else stays the same. Now, in order to solve this for t, we need to get that exponential piece, this 1 plus 0.09 to the t, by itself. So we're going to divide both sides by 1,400. Right. When we do that, 28 divided by 1,400 is going to be 2. So we've got 2 equals 1.09 to the t. Now we can use that definition of logarithm and rewrite that exponent as logarithm. Okay. Remember, the base from the exponential is still the base for the logarithm. In order to solve this using our calculator, we need to use the change of base formula and divide the log of 2 by the log of 1.09. That will give us the time. T is approximately 8.043. I want to see that value rounded to the nearest thousandth, but then when you go to answer the actual question, nobody says it'll take 8.043 years. Rounded to the nearest whole years. It will take about 8 years for the value of the painting to double. Make sure you answer the question in a complete sentence. Okay? So now it's your turn to try a problem. This one should also be familiar. So I'd like for you to pause the video and give the math problem a try. When you're done, go ahead and continue the video. The answer key is on the next slide. Make sure you paused and tried the math problem before you go to the answer. So again, this problem was exponential growth. So here's my formula. Here's the math problem. We start with 14 gazelles. So we replace P with 14, and it said that the population increased by 8% per year. So we put 0.08 in for the growth rate. Triple is multiplied by 3, so we're looking for when the population of gazelles will reach 42. Did you divide by 14? Then use the definition of log. Use change of base. And then round your answer to the nearest thousandth. So make sure you wrote your answer in a complete sentence. It will take about 14 years for the gazelle population to triple. So how'd you do? All right, so second example. Here you're the stock market genius. You started with $875 in stocks, but the value started decreasing at a rate of 3.04% each year. The value started decreasing, so this time we're using exponential decay. Our starting value was 875, and our growth rate as a decimal is 0.0304. The question that we're trying to answer is how long will it take for the stock to reach 200? So we replace A with 200, and then everything else is essentially the same as the first example. We need to get the exponential piece alone, so we divide both sides by 875. We then rewrite our function as a logarithm. We use change of base. And then round our answer to the nearest thousandth. Okay. Again, don't forget to answer your question in a complete sentence. It will take about 48 years for the stock to be worth only $200. Okay. If you have any questions, ask your neighbors. You guys can work together pretty much all week except for on Friday when you're taking your unit test. If at any point I'm moving too fast, you are more than welcome to stop the video, rewind, replay as many times as you need to. Go ahead and pause the video and give this math problem a try. You're going to set it up just like the example I just went over. Really, pause the video, give it a shot. Let's see how you did. Again, this is an exponential decay. So here's our formula. We're going to replace the initial value and the growth rate, or decay rate in this case. Okay, 11% as a decimal is 0.11. To start solving our problem, we want to know when the laptop is worth only $1,000, so we replace A with 1,000. We divide both sides by 2,300. Rewrite it as a logarithm. Use change of base. And notice what I did here. 10,000 divided by 2,300 can be reduced to 10 over 23. Okay, I'd rather you leave it as the fraction, but if you do end up dividing and changing it to a decimal, please make sure you round to the nearest thousandth. Okay, 3 decimal points behind the decimal, or 3 places behind the decimal. Okay, here's our final answer. So to answer our question in a complete sentence, the laptop will only be worth $1,000 after about 7 years. Okay. On to the next example, compounding continuously. Okay, we invest $700. That is our initial value. We're given a 2% interest rate compounded continuously. And we need to find out how many years it'll take for that $700 to increase to $1,000 in savings. Okay, so $700 is our initial value, 2% is our growth rate, and $1,000 is our new value. I don't want to get rid of that all at the same time. So here's our formula. PERT. Okay, when we're talking about compounding continuously, we need to use that natural exponent of e. Okay. This would be the function rule that represents the situation. If you are explicitly asked for that function rule, here it is. Okay. Again, that function rule only contains the initial value and the growth rate. 2% as a decimal is 0.02. When you go to solve the problem, that is when you replace A with the new value. Okay. Just like before, we're going to divide both sides by 700. And then we're going to rewrite this using the definition of logarithm, but instead of using log base 10, we're going to use natural log because our base was e. Okay. Then this one ends up being easier. We take the natural log of 10 over 7 and then we divide that answer by 0.02. Okay. Round to the nearest thousandth. To answer the question, write a complete sentence. It takes about 18 years to have $1,000 in that savings account. Okay. Now it's your turn. Give it a try. Pause the video and try the math problem. Okay. Hopefully you guys are still awake. We got a couple more examples to go. So how'd you do? This one was a little different. You had 2 tasks. The first was to predict the balance in the account after 5 years. This is how we were solving problems earlier this year. Okay. We write our formula. We replace it to write a rule for the situation. So we replace the P with the initial value and the R with the growth rate. 10% is 0.10. But because we were given a time, this one's an easy plug and chug problem. Just make sure that you have parentheses around that exponent of 0.1 times 5. Okay. Plug it into the calculator, and here's what you get. Answer your question in a complete sentence. So the first piece was predict the balance in the account after 5 years. Oh, for some reason, I don't have the sentence. So the sentence answer is after 5 years, there will be about $8,243.61. We are dealing with money. Money gets rounded to the nearest hundredth. Okay, 2 decimal places. For the second part, how long will it take the investment to reach $15,500? That's like we just did in the previous example. Okay. We write our formula. We plug all of our values in. I skipped the writing the function rule. Technically, it didn't ask for it, so I immediately plugged everything in that I have. I do the division. I've got to get rid of that 5,000 to get the exponent piece by itself. We take the natural log, or divide by 0.10, and here's the answer rounded to the nearest thousandth. It will take about 11 years for the investment to reach $15,500. Okay. We're almost done, guys. Joey, you better be awake. All right, last example. One more you try. Sid is saving money for college. He starts with $9,000, but he needs $10,000 to pay for his first year. So he buys a GIC, which is kind of like a CD account where you put money in and it'll just accrue interest until you reach your goal. All right? That interest rate is 2.45%, and we're compounding monthly. And we want to know how many years it'll take to reach 10,000. This is as complicated as the math problem is going to get. We need to use the compounding formula, okay, where P is still your initial value, R is still your growth rate, but this time we're compounding, so we need to divide the rate by the number of compounds. In this case, it's 12. And since we apply the interest 12 times a year, we multiply that by our T. Okay. So I'm going to replace all of my values. 9,000 was the initial value. 10,000 is our goal. Here is my rate as a percentage. I'm compounding 12 times a year. All right. We're solving for T. So we start the same way as we did all of the other problems, where we're going to divide 10,000 by 9,000. Okay. But this time, we've got to take the log of both sides, because now we don't just have T as an exponent. Okay. So I take the log of both sides. I can bring that 12T to the front using the power rule of logarithms. I'm going to pull out the T, because remember, the goal is to get T alone. And then I'm going to take the log of 10 divided by 9 and divide that by everything else except T. When you plug that into the calculator, here's what you get. It'll take about 4 years to get to $10,000. Okay. You guys have one more you try. So here it is. Go ahead and pause the video. How'd you guys do? Hopefully you got this one right. If you didn't, find somebody in the classroom who did. Maybe they can explain it to you. Or rewind and watch the example again. Your math homework has 13 problems. You need to do at least half of them tonight for homework. You should have some time in class tomorrow to finish. Just remind the substitute that I said that's okay. See you guys next week.